In this presentation, we're going to discuss about compilation and linking. So basically, the generation of a binary from a C source code consists of three stages. First stage is the preprocessing stage. In the preprocessor stage, the preprocessor will replace all the preprocessor directives to the actual code, as we have seen in the presentation on preprocessor, like conditional compilation, hash defines, hash include, etc. Most compilers remove comments in the source code at the stage of preprocessing, and the preprocessor will make the content ready for compilation. As we have seen before, the Microsoft C++ compiler can give the output of preprocessor using the /p option. So for all practical purposes, we can assume that preprocessor and compiler is one and the same thing, except for some macro related compiler errors and when you debug. Sometimes you have to go into the macro while the debugger is showing the problem with the macro. In Visual Studio, preprocessor is implemented in compiler itself, which is the Cl.exe. We have seen this demo in the presentation related to preprocessor, so I would recommend you to watch that. So now the stage 2 comes. Stage 2 is compilation. So compilation itself is divided into two, front end and back end. So I'm not going to discuss that. So the output of the preprocessor, which is again text, is given to the compilation unit. So it is a compiler which generates the equivalent assembly code. So what are the input to the compilation unit? The C files or the C++ files, .c or .cpp, and all its dependency headers like hash include, stdio.h, windows.h. From whatever header files the functions are being called in the C files. So those are the dependency headers. Then the compiler options. So three things: the source files, header files, and the compiler options. Those are the three inputs to the compiler. The main output of the compiler is the object file or .obj file. So a little bit about the obj file. As expected, the obj file contains the assembly code equivalent to the C file we have given. It is only understood by the linker. It has a format called portable executable or PE format, which is similar to the final binary, but it's not exactly same. It's a very famous format in Windows, which all the binaries are made of. So a little bit about compiler options. Numerous options are there. It's all documented in MSDN. It is very important to understand most of the compiler options. Optimization is the most important, which controls the generation of code. So most of them can be modified by changing the Visual Studio project settings. So we'll see that in a demo. So we have a program in Visual Studio here. So this is taken from the presentation regarding multi-files, same project. So we have 1, 2, 3, 4 source code files. So if I build this, and if I open the build folder in Visual Studio, if I go to debug folder, I can see 4 object files. So each source code file will create corresponding object files. So as I mentioned, object file is of format PE, so we can prove it using dump bin. So dump bin you can open from this particular location. So for example, my Visual Studio is installed in C program files. So I got a 64-bit machine, so I have opened the 64-bit version of the dump bin, AMD 64. So what I can do is I can apply the switch /all, and I can look at the obj here. So pretty much it has dumped out the information regarding the obj. I'm not expecting you to understand any of this. but just proving that obj file is of PE format. Dumpin is a tool which dumps out all the contents of a PE file. So now let's have a look at the compiler options. So these are the inputs to the compiler. So the CPP file and the header files. So one of the things we have discussed is one CPP file and its dependency is compiled at a time. So that is called a translation unit, or TU. So one TU is one CPP and its dependency headers. So in this case, this particular multi-file 1.cpp got two dependency headers. One TU will produce one object file. So mostly that is a case of a CPP file. So one CPP file will produce an object file. Compilation of code1.cpp is independent of compilation of multi-file 1.cpp or any other CPP files. At a time, compiler concentrate on one single CPP file and its dependencies, which are the header files. So if you go to the project properties, you can see a tree node here called CC++. So this is basically the compiler options. So you can see numerous options here, numerous different settings categorized as different nodes. Not all the options are present here, although we have all the most important ones. So if you want a compiler option which is not present in any of these options, you can edit the command line to the compiler directly here. This is the command line which is going to the compiler. So this command line switches are set by these options. So I recommend you to read through a couple of options. Some of them may not make complete sense to you, so try to read about that. So that is also part of understanding the language in deep. You have a small description up here. Sometimes it's not helpful to understand it completely. This part I am giving you as an exercise, so you can use any search engine to find out the complete documentation of the compiler options in Microsoft Compiler. So the final stage, which is the stage 3, is the linking. So as I mentioned in the presentation regarding multi-files, any production program, there are so many C files are included. All those C++ files are compiled to corresponding obj files, and it is the linker who is connecting this obj file into a single program which can be executed by the operating system or the loader of the operating system. Linker will also generate the debug information which helps to debug that particular program. All these breakpoints we were giving, watch variables, all are working with the help of PDB files which are created by the linker. So what are the inputs to the linker? Object files from the compiler and the dependency library files and linker options. So the dependency library files are header files equivalent at the linking stage. So we are giving header files at the time of compilation. So now we have to give the definitions of those declarations at the time of linking. Those definitions are present in the lib files or the library files, .lib files. For example, in the case of a printf function, the declaration is in the header file stdio.h, and the implementation or the linking information of that particular file or the definition of that particular function is present in stdio.lib, which is to be given to the linker at the time of linking. What is the output of the linker? It is a final binary which is either .exe, .dll or a sys file plus the PDB file. So in our cases it was an exe file. We didn't make any DLL or sys file so far. Most of the optimization is done at the time of compilation when you generate the assembly code, but some of the optimizations are done at linking phase as well. One example is the comdat folding. So when you build a project, you are doing all these 3 stages in a single shot. So this is the final output of the linker. So these are the two main files linker produces. So I'm not going to explain this file, it is Microsoft specific. So this is the debug information, and this is the final binary which is created by the linker. So we have seen the obj file before. In the Visual Studio project properties, you can see a node called linker. So this is pretty similar to the node here. So you have all the options, different options here. These are linker options or linker switches. At the end you can see a command line which is passed to the linker. So if there any option which is not present in here but it's documented, you can use it here as command line. But most important options are available here. So have a look at this again and try to read about it as much as possible. As I mentioned, some of this may not make much sense to you, so try to dig into that particular area. So finally I wanted to show you the compiler and linker themselves. So this is the Cl.exe. It has a couple of dependencies here, and this is the link.exe. This is a linker. So this is in this particular folder in my system. You can use this exes, Cl.exe and link.exe, to build the binary without using Visual Studio, where you have to pass the correct command line arguments. Let's review the compilation process. So compilation process contains one single CPP file at a time, or C file, with its dependencies. What are the header files included in this CPP file should come here, and we are giving that to the compiler as input. The compiler, which is a Cl.exe, along with the compiler options, produces the object file. Object file contains the assembly instructions corresponding to the code in this file. So x.c will make x.obj. So this is a summary of the linking phase. So this is the obj file which we wanted to link together. So it has dependency with lib files, and we are passing everything into the linker to link it together, and we are getting the output, the exe and the pdb file. So this is the overall summary. So this is a TU, or translation unit. This is another TU. So each TU is passed through Cl.exe. So sometimes resource compilation is also happening, which I didn't explain. Just like source code, instead of the compiler you use the resource compiler. So all these object files we are giving to the linker to link it together and make the final exe with the PDB. So that's it. Thank you very much.